What if one platform covered everything from idea to market-ready product? A platform teaching all the AI tech and practices needed for successful AI-driven startups.
This is like AI imagination.
We found that the more specific we are,
we used a classifier, we trained the classifier.
I really wanted it to just be more open-ended for the user.
We were experimenting with different chunk sizes,
having some problems to something.
By blending cutting-edge technologies from industry giants, you can create revolutionary AI products that drive innovation forward.
This was a special hack, it was a battle.
Let the hacking begin!
Hi everyone, and welcome to the official kickoff of our special event that is Aria and Allegro Multimodal Hackathon. Why is it special? Because out of all registered participants, we carefully selected 10 teams who will get a chance to get an access to Rhyme's AI newest models, Aria and Allegro. So I hope you're ready, because today, 1st of November, we'll find out which teams will take part in this exciting challenge, and we'll have 2 days to build something that will truly showcase the power of those two models. You can call me Jay, and today I'm going to be your host, and I'm here to tell you about the event schedule, about the challenge and judging criteria, and to give you the platform walkthrough. But let me start with the warm welcome to those who are watching us right now. It's great to have you here. As always, we'll be monitoring the chat, so please stay active, don't hesitate to ask questions. This space is for you. As I just mentioned, this hackathon will take 2 days, and to the all-approved teams, this is your chance to build something outstanding by integrating text, images, video, and code with Aria, or create stunning videos using text-to-video model Allegro. The deadline for submissions is planned for 3rd of November at 6 p.m. Central European Time, and before that time, all the deliverables should be submitted on our platform. And also don't forget about the joining Q&A session on our Discord that will happen right after this kickoff at 7:30. This is your chance to talk to mentors, ask questions, and get early feedback on your project proposals. During the stream, except for the introduction, we of course have some amazing guests for you. Simon Olson, co-founder of New Native, will tell you more about LabLab AI. Dong-Soo Lee, research scientist from Rhyme's AI, will introduce you to their company and products. But the real deep dive into the Aria and Allegro models will happen after the platform walkthrough, because Noah Maisel, engineer from Rhyme's AI, is here to give you the workshop, where you will be more than welcome to ask technical questions. So stay with us until the end. All right, without further ado, I would like to welcome to the stage our first guest, Simon Olson, co-founder of New Native. Hi Simon, the stage is yours. Yeah.
Thank you. I'm very excited about this event. This will be super fun. This is actually one of the first ones where we do super exclusive access to some of the new models coming out. We've been very fortunate to have Rhyme partner up with us for this, and I'm very super excited. So first and foremost, congratulations to everybody that actually made it to this event. This is a very exclusive event. We have a very limited amount of spots for it. So congrats on getting in. This will be a super fun 2 days. So both of these models are fairly unique. I've played around with them actually a little bit, and it's amazing. I especially like their Aria model, but I really liked the vision, the imaging models and the video models. They are they are amazing. So I have very high expectations for the output of this event, and I hope to be really blown away by what you will create. And so thank you very much to Rhymes for doing this event together with us. I'm excited. I hope you guys are excited, and I also looking forward to some really cool stuff. So thanks a lot, and best of luck to all of you guys participating in this. It is a very niche and elite group of people that has been selected. So we're with high expectations. Back to you, Jay.
All right, thank you. Thank you, Simon. Thank you for being here. And now I would like to welcome our next guest, Dongsu Lee from Rhymes AI. Hi, Dongsu. Great to have you here. Stage is yours.
Hey, thanks, Jay. Welcome everyone to our Multimodal event today, and huge thanks to all of you for joining, and also a big shout out to LabLab AI for hosting us today. I'm Dongxu, a researcher at Rhymes AI, and I've had the privilege of leading the development of the Aria model this year, which we'll be using in this event. Before we dive into the more technical, detailed part, I'd like to share some of the ideas, some of the core principles that guided the development and the design of Aria model. We think these are quite important aspects for making the Multimodal AI practical, powerful, and also useful for our daily tasks. So there are actually four main aspects we focused on when we designed Aria. First, we built Aria to handle the high volume multimodal data. Think of the long videos, dense documents, and all this kind of hefty content. Processing this type of data manually would be exhausting. So automation here with multimodal AI can be a real productivity boost. Second, we aimed for high resolution support. Aria handles large and complex images, so it can dig into content-rich visuals such as menus, posters, financial reports that we actually care about in our daily life and work. Third, Aria is built to be truly multimodal native. I believe we have seen many multimodal open source models can caption images or answer some basic questions about them. But Aria goes even further here. Beyond reasoning on images, it also handles coding, math, and also natural language reasoning as well. It's really like an open source version of GPT with a broad skill set and diverse modality support. Lastly, we want to emphasize that Aria is really accurate and efficient at the same time. With this specially designed architecture, Aria delivers best-in-class accuracy with fast inference speed. Making it incredibly interesting, funny, and easy to use. And even more exciting today, we also have Allegro with us for the video creation from text prompt, I believe, which also further expands the possibilities of what multimodal AI can achieve. Now, I think I will just hand over to my colleague for more detailed instructions, and really hope everyone has a super great time and enjoyed the event, and looking forward to see all the amazing things we can create here. Back to you, Jay.
All right, thank you very much. And yes, we are super happy to be able to organize this hackathon with you. And I'm very curious what will be the outcomes from the participants. Hope you too. But okay, for this hackathon, we promised you access to Aria and Allegro's API keys to 10 pre-selected teams, but we have a surprise for you. Rhymes decided to gift 2 more teams and grant them the possibility to join as well. So now instead of 10, we have 12 teams that will be competing with each other. And here on the slide, you can see the list of those teams. If you're on that list, you will be invited to the private Discord channel just for the participants of this hackathon. And the emails with API keys has been already sent to the team leaders. So if you didn't check your mailbox, you should definitely do it now. Now, let me tell you a few words about the challenge. We want you to develop innovative solutions that integrate multiple data types such as images, text, video, and code into cohesive, intelligent applications using RHYME's AI powerful multimodal models, Aria and Allegro. And the key objectives are to use Aria or Allegro as a foundational model to develop your application, and your solution must be an open source shared through GitHub repository. And something very important to keep in mind while building your solutions relates to compute resources. Aria allows unlimited tokens at a rate of 120 requests per minute, while Allegro supports one concurrent video generation request per team. If you have any questions about the challenge or limits of computation, please keep them for the workshop segment, because I don't think I could answer them better than our guests from RHYME's AI. Or remember that we already provide you support on Discord, so you can ask mentors any questions you want. And moving on, I'll tell you about the evaluation process. We are going to judge you based on 4 criteria. Application of technology, so how effectively you integrate the chosen models into the solution, the potential impact and the business value, the originality and creativity in addressing the challenge, and the final pitch presentation of your project. When it comes to the prices, except of course for an exclusive access to Aria and Allegro models, 3 out of 12 teams will receive cash prizes. The winner of the first place will receive $3,000 in cash. Second place will receive $1,500, and third place $500 in cash. And during the winner stream, you will have a chance to present your solutions in front of the judges from RHYME's AI and get super valuable feedback that will help you to improve your skills. So it's super, super worth to be there. And for this hackathon, we have prepared for you 3 tutorials that will help you to start with your projects, and you can find them in the tutorials section on our platform. All right. In this part, we normally give you the platform walkthrough, but because this is the special event and the teams have been pre-selected, I'll just make it short and will mention only information that will be relevant for you in this hackathon. First of all, I would like to introduce our amazing mentor leads who will be assisting you throughout the whole hackathon. You can ask not only technical questions, but also those business related. So don't hesitate to contact them. They will be waiting for you in the dedicated Discord channels. And here on the slide, you can see their usernames. But except for our mentor leads, who you already know, we have invited RHYME's AI mentors as well, who will make sure to assist you with any technical support you might need. And you will recognize them by the tag RHYME's AI mentor. Now, what does the process of taking part in the hackathon look like? You already have a Teams, so now you can create the private Discord channel to be able to communicate. You can, of course, use different communication channels. It's all up to you, but remember that all the support we provide for this hackathon is happening there, and it's also easier to contact mentors. Then we recommend you to come up with 2-3 concepts of your application and ask mentors for review, for feedback, and for the green light to start with your projects. And from that moment, start building your prototype, cooperate with each other, deliver your tasks, and at the end of the hackathon, submit your solutions and product presentations on LabLab AI platform. And remember that the presentation is very important because it will basically form the first impression of your project on the judges. If you want to read more about the whole process, go to our platform and you can find their LabLab AI guide that covers everything I just mentioned. And here is the QR code that will help you to find it. As I mentioned before, if your team has 2 or more team members, you will be able to create your own Discord channel, and it will allow mentors to communicate with your team. But on your team page, you also see the toggle to call for help. If you'll use it, mentors will receive notification and will jump into your Discord as soon as they can. And talking about mentors, they're available for you throughout the whole hackathon on the general and private Discord servers. So use tag mentor to ask the question to our mentor leads, or tag RHYME's AI mentor for help from the RHYME's AI team. There are many Discord channels that might be useful for you during this hackathon. There are channels where you can ask for help, look for important information, but the most important channels for you are those dedicated to Aria and Allegro Multimodal Hackathon. All right. At the end of the hackathon, you will have to submit your project. What we require from you is the product description, each presentation, and GitHub link with the demo. Remember that the presentation cannot be longer than 5 minutes, and please make sure that your demo link is working, because if we will be missing any of the deliverables, your project won't be eligible for evaluation. If you want to read more about the submission guidelines, scan this QR code and you will find the article with all detailed description. Before the deadline, you will have to submit your project through the submission form using this button that you can see on the slide, and you will find it on your team page. One more article worth mentioning. We have prepared for you some tips on how to be successful at the hackathon. You will find there 7 steps to crafting a winning business idea, from brainstorming to execution. And you can find it by scanning this QR code. That was it when it comes to the platform walkthrough. To make your life easier, I will paste all the links from the QR codes in the chat. And now it's time for the workshop. And this is your chance to ask any technical questions about the challenge or the computation limitations, or you can just write something nice to our guests today. But without prolonging anymore, I would like to welcome to the stage our next guest, Noah Maisel, engineer from Rhymes AI, who will give you the introduction to Aria and Allegro models. Hello, Maisel. Thank you very much for being here today. Stage is all yours.
Hi, thank you for having me, Jay. Can you see my slides properly? Just want to confirm that. Okay,
Yes.
so I think I'll just get started. So this is an introduction to Aria and Allegro, and my name is Mazel, and I'm engineer at Rhymes.ai. So a brief little introduction. So maybe no one ever heard of us, right? So we're a new company. So we are a team of experienced researchers and engineers based in California and Singapore, and I'm now actually in Singapore. We're actually building the next generation of advanced multimodal AI. So we're a very small team and we're just getting started. So GPU resources are really limited. So our purpose is that we want to build really fast and powerful and intuitive AI designed for everyone. We're also open sourcing 2 of our models. We try to push the boundaries and showcase the potential of the open source community that we've seen over the past 2 years. And also we want to amplify the human creativity with seamless and multimodal experiences. That's our purpose. So what is this seminar is about? So this is just a heads up. So first of all, this is not a research seminar. And I've seen a list of all the participants, and I understand many people doesn't really have a background in the field of AI. Maybe you are let's say a backend engineer or a front-end engineer, but don't worry. We'll just actually briefly explore all the key technologies to give you a clear picture of the whys and hows, how the model works, how did you train this model. I'll try to keep things very simple and very straightforward. So if you are a researcher or if you are a very professional AI guy, you can also check the details in our tech reports because those are the more accurate ones. Okay, so let's get started. The first part will be Aria. So what is Aria? We actually released this. We believe that this is the first open source multimodal native MOE model. We released that on October the 10th. So a couple of features. So it's a multimodal understanding model, which means that it takes in images, videos, text or code, and it output text. So it has the best-in-class performance on a wide range of multimodal and language tasks. It's competitive against proprietary models like 4.0 Mini and Gemini 1.5 Flash. It actually is an MOE model with 3.9 billion activated parameters per token, and which means that it's extremely fast when you do the inference. Also, we're able to extend the context window to 64K, which is basically equivalent to 256 video frames. And our model is really good at long context modeling. And also we've opened all the model weights on Hugging Face, our code repositories, a detailed technical report. Everything is Apache 2.0. So feel free to adopt our code, our model, make a fork, etc. So this is basically an overview of Aria. So you might be wondering, why did I say multimodal native model, right? What does it mean? So this is a term that we want to define. So a multimodal native model refers to a single model with strong understanding capabilities across multiple input modalities. For example, text and code, and because code is usually considered to be a different modality because the way of thinking or the way of expression is very different from the ordinary text that we use, plus the images and videos that actually can match or exceed the modality's specialized models of similar capacities. So the important thing to keep in mind that this is just one single model, right? We already see many multimodal understanding models out there, but they usually have very poor, or we actually see declined text performance. So just a recap. Let's. I'm assuming people are very familiar with large language models, right? So let's do a quick recap. So large language models basically does this next token prediction, right? So if we give a sentence that Dartmouth students like to do what, right? So we pass that through a language model, and we see. So for different words in the vocabulary, you get a corresponding probability. So the loss value that you get is that given all the previous words, can you actually accurately predict the next word? Okay, so this is actually from Jason Wei, this image here. So credit to him. And also, for many of these early VLMs, or like Lava style, all these multimodal understanding models. So what's the difference here? So for the early VLMs, usually they combine a pre-trained large language model plus a vision encoder, which is VIT, which is used to extract the features from images. So these two things are connected by a projector. The second point is that they usually do post-training on the projector, but usually what we see is that the post-training is insufficient. So they try to align between the different modalities, but actually the alignment isn't do very well. So the result is that we see less than ideal performance, and it doesn't really generalize well. So one of the things that we really think that is really important is interleaved images and text. This actually leads to a more holistic multimodal understanding. So for instance, let's take a look at the little square on the left here. So so imagine how you read a web page, right? It's not just pure text. It's usually text, images and videos, and then text. They're basically interleaved, or they're mixed together. So the term interleaved images and text basically makes different parts of the images and text, and the image and text. So these things combined together in the pre-training process can lead to a more holistic multimodal understanding process. Okay, so let's look at let's look a little deeper. So as we can see here, we have the Aria model, which is an MOE model. You see different experts here. And during the pre-training process, we have the text that we see here. And also we see image and charts and diagrams, and also videos being chunked up into different image sequences. So these things passed into a vision encoder, and also a projection module. And these things mixed together with code form the corpora, so-called corpora, or the materials that you need for the pre-training process. Okay, let's dive a little bit deeper. So for the training recipe of Aria, so the first step would be language pre-training. So just like how you would train a dense model, that's for instance, let's say a Llama or a Mistral, which is amazing open source models. And we actually use 6.4 tera tokens to do the language pre-training. So the second stage would be multimodal pre-training. So we are basically, like I said, we're mixing different language tokens and also multimodal tokens, which is basically image tags and captions, QA stuff. So the multimodal tokens are around 400 billion tokens, but mixed with around 1 trillion tokens of text. And the third stage would be long context pre-training. So we're basically trying to extend the context length from, let's say, a shorter version of, for example, 4K or 8K towards a longer one. So in this case, 64K. So in this process, we actually utilize 12 billions of text tokens and also 21 billions of multimodal tokens. As for the final stage, which is the multimodal post-training, it's just like how you would do post-training on language models, right? You are basically using QA pairs, questions and answers. We actually use the multimodal ones. And for that part, we have around roughly 20 billion for the post-training part. So these 4 training parts, form the final Aria model, which is really amazing. So how amazing is that? I keep saying the word amazing. So here's some benchmark results. So Aria really performs really well in terms of complex text and visual tasks. So let's take a look here. So for instance, we have MMMU, which is multimodal word knowledge. We also have MMLU here, which is commonly used in language-only tasks, which is just multiple choice questions. And also things like human eval for coding and stuff like that. So as you can see here, the benchmarks that we choose contains, language tasks, knowledge-intensive tasks, coding tasks, and also have, chart understanding documentations, and also these different multimodal benchmarks. So as we can see here, Aria basically consistently beating Pixtro and Llama 11B version, and we're really proud of that. And also take a look at the long video bench, right? You can see here we got a 65. Meanwhile, the Pixtro and Llama only got like around 45 to 47. And what is noteworthy is that for the benchmark of Aria, we also beat GPT-4o Mini and also Gemini 1.5 Flash. So which means our model is really competitive even compared to some of these proprietary models out there. Cool. So to help people better understand, how our model works, we provided many examples. For instance, this example is image understanding. We offered a sample inference notebook. You can actually find here in this GitHub repository. You go to rhymes-AI, rhymes-AI, and go to Aria, and we have these different inference example notebooks in a folder here. So in this example, when you only have just one image, or let's say multiple images that you want to compare or whatever, so this is the sample inference notebook for there. And also remember that let's say pay attention that these are higher resolution images. So there's this image split in the flag here in the function here. So pay close attention to that, because what we discovered is that for higher resolution images, you will actually have a better results when you actually split the images into different parts. But you don't need to worry about any of these details. You just need to set the flags, the split image into true. So this is for image understanding example. Also, what you can find also in our GitHub repository, marked down in the bottom right corner, is a PDF understanding example. So what's so special here? So if you are very familiar with PDF files, you will know that it's actually pretty complicated stuff to process, because the PDF files really renders in a format that human all understand. But we find out that for algorithms or for PC or Mac, it's actually usually the software struggles to correctly identify the layout of the PDF file. So in the past, people have been trying different methodologies of extracting the pure text out of the PDF, and if the format somehow screwed up, they try to rely on large language models to understand the text with the wrong formatting, and also they try to use some sort of visual language models to identify the layout of the PDF, so they can actually zoom into those charts or maybe sometimes graphs or pictures to try to understand that. So in this example, we actually demonstrate a different approach, which is that when you have a multi-page PDF, for example, like an archive paper or a financial report or some slides or scan books, you can actually turn those PDF files into a series of multiple images. And the different part is that you can actually feed all of these PDF images and directly into Aria. So you can actually see in the prompt here that please provide an detailed summary of this paper, or you can ask the Aria to help you do a detailed analysis of a specific chapter, or do an ablation study, whatever, things like this. So to be honest, Aria is really, really good at doing this. So I encourage to give it a try. So if you have experience with other vision language models, you will notice there's a huge difference here. Okay, cool. So this is the PDF understanding part. Next part would be the long video understanding. As we said, Aria is extremely good at long context stuff. So Aria is actually able to understand long videos with more than 100 frames as input. So which actually means that you need to change your videos into a series of image sequences. And so you can actually ask Aria to summarize a long video with details, with different scenes. And also a different thing that you can do is that you can cut a long video by scene transitions with timestamps. So actually returns the information with different timestamps and tell you what event happened at which timestamp. So there's a quick note here. So for now, where Aria doesn't really deal with audio input. If your audio has, let's say, a dialogue or a human talking, you can try to use you can try to convert that to pure text and use that text also as an input prompt. That's one thing you need to note. And also videos, we actually see that people try to feed the entire MP4 or .mov file, the entire video file into Aria, and it actually doesn't work that way. So you need to break the video into an image sequence in order to feed into the model. And also, you don't really need to do that for every frame, right? You can actually consider, depending on your different usage, you can actually have 1 frame per second or per 4 or per 5 seconds. Or even you can actually use some really smart methods like basically scene-based segmentation, or let's say adaptive frame rate, stuff like these. So it's really up to you to decide which method you adapt. So you can also find the example notebooks here in our Aria GitHub. Finally, I think this is another thing, which is framework, fine-tuning framework. So this is, I would say this is more like for hardcore researchers who really want to wanted to boost on their specific downstream tasks, right? So here we provide a framework dedicated to Aria model fine-tuning because Aria is pretty special. It's an MOE and it's also a multimodal. So that's why we have this fine-tuning framework together with 4 different guides. The guides including the single image dataset, the multi-image dataset, a video dataset, and also a code dataset. So I have a little bracket here says it's text only, so which means that you can actually use Aria as a pure text-based dataset. You can just treat it as a large language model to do some fine-tuning. So it's actually cool with that. Some may be asking, so why would I need that at all, right? So I would actually encourage you to check this. The first one is called RefCoco. So the RefCoco dataset, which is something like it's more like an object detection dataset. So if you are a more traditional CV person, then you're extremely familiar with stuff like faster RCNN or like YOLO. which or even we have SEM now, segment anything, which that given an input image, you are trying to predict the output bounding box, the coordinates of the bounding box. So if you check our fine-tuning tutorial, you actually find that if you fine-tune on RefCoco example, the accuracy rate increases like significantly. So if you try to do this task, this is one of the things you can do. And also, we also support both LoRa and also full parameter fine-tuning. So take a look. It's actually pretty fun. Right. So as for API usage, for our hackathon event this time, so I'm not gonna cover it because it's actually way easier if you just check the documentation provided by LabLab. Thanks to team at LabLab, because they've actually gone through the entire thing and their documentation is pretty thorough. And as for a more detailed analysis of all these different parameters and how does these parameters works, we will offer a different a documentation of details in our of how to use our API, and also our mentors will actually be in our Discord channel as well. So feel free to ask that. So I'm not really gonna go through this because it takes some time, and it's actually pretty easy if you read the documentation really carefully. All right, cool. So this actually concludes Aria. Let's see if there are any questions.
Not
Oh.
on
Okay, cool. So we will actually proceed to, now it's time for Allegro. Okay. Now, what is Allegro? So Allegro is the best open source text to video model available right now, in its class, of course. So first of all, you have a input text prompt, which basically is just a string of text, and the output will be a 720p resolution video at 15 frames per second that lasts for 6 seconds. You can also use additional tools like EMA VFI that can do frame interpolation, that can boost the frames from 15 frames per second up to 30. And I know for a fact that there are actually many methods out there that can further increase the frame rates up to 60. And also there are super resolution tools that you can bring let's say a 720p video to up to 4K. So these are the additional tools that you can feel free to adapt. So on the right, it's just 9 different demo clips that we put on our website. But if you want to check for more details, you can actually go to our rhymes.ai website and /Allegro gallery. So on this gallery, we're actually putting many, I think we put like 30 or 40 different video examples together with their corresponding prompt. So you can use that as a reference. So here's a video. Let's just take a look. So this is a really nice video made by our team member. This actually depicts the different movements of a crowd of people and also animals. It's pretty vivid. And here are some faces. Here are the robots. A little creepy, I would say, but they do look pretty sci-fi. And these are foods, kebabs, some steak. Man, I'm hungry. So this is generating 6-second long video footage. Some wedding. Tram on the street. Some time lapse. It's also doable. Some supernatural video clips as well. That almost seems like real to me. All right, cool. So I just showed you a very cool little video demo that our engineers has made over the past couple of days. So I'm gonna dive more detailed, technologies behind Allegro. So, again, Allegro is a powerful AI tool that can transform simple text prompts into high quality and short video clips, opening new possibilities for creators, developers, and researchers in the field of AI generated video. So its features, first of all, it's open source Apache 2.0, and that's our core value. And also, it actually enables versatile content creation. Well, I think we already covered that Allegro is capable of generating really high quality video output. And remember, it's pretty small and efficient. It's actually two different models. It's actually a 1.8 billion parameter DIT model, diffusion transformer model, and a smaller VAE model. So to understand how this works, you need to have a little bit of sense of how diffusion works, right? Diffusion is the common algorithm behind all these, video generation or text generation behind it. So basically, diffusion model generates realistic data by gradually adding noise to data and then reversing the process step by step. So the core idea is to reconstructing the target data from random noise. So as we can see here, it's a very cute golden retriever here. So we're actually trying to add different noises and try to learn this process, right? This is the training process. So when the learned noise pattern is done, then we can actually, when we do the inference, then we can start with we can start from just a random noise, and then we're trying to predict the noise and subtract that, doing that process reverse. So finally, we can actually have the original image as the generated one that you see. So this is the diffusion process. So how do we actually train such a visual arts master? So we think there are actually three main pillars here. The first one is data engineering, right? Which kind of right data should you use? The second one is model training. You should think really big, but you should start with small steps. The third pillar is assessment, because human creativity is really boundless. It's really hard to measure using numbers. So how do you actually create assessment properly? If you are an academic researcher, I encourage you to check our research paper here. You can also find the link in our both the Hugging Face model card and also in our GitHub page as well. So here, the first part will be data engineering, and the keyword is restraint. It's kind of weird. Let me explain. So rather than relying on excessive amounts of training data, we really want to focus on really high quality data, just like you would balance your your meals 3 times a day, right? So restrain your desire to modify model structures. Instead, focus on optimizing the data quality. So as we can see here, so this is a little graph depicting the 4 different training stages that we use. So originally, we prepared a large amount of, really large amount of video data for pre-training. But based on many experiments and many attempts that we've done, we actually discovered that the data retention rates are finally like from 25%, and gradually and lastly, we actually dropped to less than 1% in our final fine-tuning stage. So as a comparison, there's a really amazing model. It's called Meta's Movie Gen. It's not really open source, but they have their paper out, and they actually have a final data retention rate of less than 10%. So which actually verifies our thought, because when they announced their movie gen, we are actually in the final stage of releasing our model. So cool. So the second part is training, and the keyword is progressive. So you should think of the training process in different stages, step by step, without really rushing for a quick success or losing sight of the important priorities. So the 4 different stages. First, you do the low resolution text to image pre-training. That's really important first step. And with when the model finishes training, that you actually end up with a small model that is able to create images. And then based on that, you're adding those temporal information. So the second stage would be low resolution, but text to video training. The second stage would be boosting the resolution up to a higher resolution from 360p to 720p. And with the final stage is the high resolution fine tuning, which actually further increased the model's capability. So three remarks that we want to make. The first one is that the low resolution training, you usually get really bad results. So early low resolution training may yield suboptimal quality, but this is not the moment to abandon the training process or change your strategy. You should trust in the potential of high resolution stages. This is what we learned from our experiments. So the second important note is that the resolution guidelines. So for your original training data, 720p is the minimum acceptable resolution. If you're doing low resolution pre-training, the data should be downsampled from a higher res 720p original data. So the third note is gradual increase. So increasing the resolution of the training data is beneficial when your training resources allow, but it should be done progressively to optimize model performance. So this is a little too dry, right? So this is even too technical. You can actually refer to our tech report for the details. But basically, we actually utilize 256 H100 graphics cards for training. And actually, this is an illustration of what I say progressive training, right? So for the same prompt, we can see here that a robot is dancing on the city streets. So the first step would be a text to image 360p. So this is just a static image. We can see on the right here, this is actually text to video with a resolution of 360p. And we can take a look here. Well, it moves in a lower quality and in a lower resolution. So in the bottom left corner here, we can actually see the third stage would be text to video. We're moving the resolution from 360p to 720p. Where's my mouse? Okay, here. So as you can see here, you can see here the image quality and also the average the clarity and also the contrast boosts significantly, but it's still not there yet, right? So for the final stage is text to video fine tuning 720p. So this is more like a supervised training process, and we usually used a less than 1% of the original training data. And let's take a look here. Right. So we can actually see here the robots. Well, it's a little weird. It's a little uncanny, but it's actually pretty sci-fi. And it's actually walking not just city streets. It actually appears to me like New York City here. And it's pretty amazing. So we can actually see here these progressive training actually use significantly different results. Okay. And I also higher quality results. So this is progressive training. So for the last one is evaluation. The keyword is real life experience. So first of all, we want to say you should do something beyond metrics, because no exam score can actually truly capture the complex abilities needed for real world applications, right? You can't really possibly try to enumerate all these different categories of the prompts that people try to create, the videos that people try to create. It's just impossible to do that. So we basically try to focus on a broader focus. So we emphasize the comprehensive video generation capabilities and also the subjective experience of the users. I'm not gonna go through the details here. The bottom part, you can actually check our paper for that. But essentially, we actually conducted a user study, right? So basically, for the same prompts, we're actually generating video from all these different text to video solutions, and some of them are the commercial grade, proprietary, and you need to pay for that. You can actually see here we have different criteria. For instance, the appearance, aesthetics, and also the motion, amplitude, and also overall quality. So you're actually comparing two different examples. So by measuring the win rate, we actually observed that our model actually performs really well. So it's a double-blind test. That's why we are very confident to say that our Allegro model is currently the best open source model out there. Okay, so, but we have to be honest, it does face some challenges and upcoming some improvements. As for the video generation process, pay attention that the video generation process is computationally intensive. So the required generation, it actually requires the generation for each frame. That is really time consuming and consume a lot of GPUs for that. There are also other, let's say, other optimizations that actually cost lower VRAM, like offloading, quantizations, stuff like that. But these usually come with compromised video quality, and we actually observed that the video quality actually compromised by quite a bit. So I would say if you have enough resources, so don't really try to use that. But you don't need to worry about for our contest, because for this hackathon we actually provide APIs for using Allegro for actually both Aria and Allegro. There is one limitation though, because our model may struggle when rendering celebrities, legible text, specific locations, streets, or buildings, because some of these, so we're not like those big corporations. We don't really use all these potentially copyrighted data, so that's why it doesn't really render celebrities. Or maybe it renders a silhouette of the celebrities. It's not that clear. So we do have some upcoming improvements that we want to make. So first of all, multi-GPU inference for speed optimization. That is actually already, I believe that is already implemented in our current API service. But we actually plan to open source that as some sort of a third-party framework integration in the near future. And also, we plan to also release not just text to video, but also text plus image to video generation. I'm going to show you actually an example in my next slide. Also, very exciting, we have motion controlled video generation, also long form storyboard style generation. So if you've played with many of these video generation products, you might know that it actually generates you can, if you want to have a minute long video, and usually you need to generate let's say shorter clips of, let's say, 5 seconds, sometimes 3 seconds. And these frames are usually very inconsistent. But for those long form storyboard style generation, we really want to achieve that an output video that's a couple of minutes long, and it's really consistent in terms of human faces and their actions, and also the weather conditions, etc. So stuff like that. Those are the upcoming improvements. So this is something coming soon. We can see here, this is a test control image to video. So basically I have a input original video, the input of the original image, and plus some text prompts to control what I want to do. For example, I want these guys to be playing guitar and singing, happy, chilling, that would be nice. And for the skyscraper, you can actually turn this image into some sort of time lapse, or you can turn, maybe, I'm not quite sure with that. I've not tested that, but maybe a picture of a summer to winter. That might be possible. Okay, so we also continue our journey, but this is gonna take longer. So we just got started not long ago. So we try to actually create the longer, richer content. So here are some really, really preliminary results here. It's not really amazing, but this actually shows the directions that we're working on. So on the left here is a really short video of a small boy riding a bike inside a castle. And on the right, it's actually a longer video. As you can see here, we try to make the consistency really good. And I understand the quality is not that excellent, but this is only a preliminary training result, and this is I think this actually illustrate our idea or our direction of working. And by open sourcing our Allegro model, we really hope that the open source community can actually join us and contribute their different ideas. Maybe they have a better approach. They can use our model as a base to do some other works. I also want to touch on the diffusers library integration, because our Allegro just merged into diffusers a couple of days ago. So you might be wondering, what is diffusers? So diffusers is a comprehensive library for AI image or video generation. I should probably add a or video generation here. So the key component is that it's actually the state-of-the-art diffusion pipelines for quick inference. So you don't really need to add, different complicated components in your code in order to run just one model. You just place it in a pre-built pipeline. And also you can see here that it actually features pre-trained models as building blocks for custom systems, so you can actually replace some of the parts. It's a very simple implementation. So if you just want to get started, you just need a few lines of code on the right. And also it has I think it's already exceeded 30,000 pre-trained checkpoints available. It also supports image, audio, and 3D molecular generation. So this is the diffusers library you can also utilize. Okay, so again, for our hackathon, we are going to provide Allegro as API. And again, you should check LabLab API, LabLab documentation first, because it's really clear, and the amazing stuff from LabLab AI has already gone through that and verified that it actually works. But for some of these really detailed parameters, please refer to our documentation. I believe we'll be sharing that real soon in our Discord channel. So that actually explains in details the parameters, how they work, and what's the optimum value, what's the default value. And if you're really getting really poor results, probably some configurations are screwed up. And also, except from using API service, this actually holds the same for Aria as well. So you can actually, if you have GPU resources, or if you have some sort of online hosted GPU, you can also run the model, or maybe some fine-tune, some customization, some adaptations on your own graphics card. And that is also warmly welcomed to our challenge. So just some quick project ideas that I have. So for instance, you can do fine-tuning and integrations to make better video results, like super resolutions and frame rate interpolation. Also, you can work on the automated workflow pipelines like Comfy UI. And I think the only limit is imagination. So do your best. We're all gonna support you on different project ideas. So this basically concludes my most of my talk. So Aria and Allegro by Rhymes AI, and since I think we've open sourced our model for close to a month now, and we've received really warm feedback from the open source community. As you can see here, our tech reports made it to Hugging Face Daily top paper. We made it to the trending models, which is it's really competitive, because you have Meta, and you have OpenAI, and also have models like Flux competing with each other. There are like 30 or 40 different open source models per week, and it's really difficult to make it to the training models. And also our developers are actually located all over the world, including United States, India, Singapore, Germany, and United Kingdom, and Russia as well. So one call for action: if you really like our models, if you really like our models, please do give us a star or like on GitHub and Hugging Face. That goes a long way in supporting our journey. That's the best applause for our work, and I would like to thank you so much for that. So in terms of contact information, you can actually find us on our company website called rhymes.ai. But I would say usually if you try to find some information, you can actually go to rhymes.ai and also Hugging Face. I think Hugging Face right now is the best entrance to go. And also from GitHub, Discord channels, Twitter, LinkedIn, we're all on these platforms. So let's keep in touch. And I think that's all, folks. Good luck and have fun. So this actually concludes my small seminar, and I think go back to Jay.
Yes, thank you so much, Mazel. Guys, I hope that this workshop was useful for you, and I'm actually pretty sure it was because honestly, since we started our workshop, I was observing the numbers and they were just skyrocketing and never stopped growing throughout the whole workshop. So it's great to see you so interested, not only on Twitch, but on multiple platforms. I just want to remind you that the stream is recorded, so you can always rewatch it. The recording will be available on our YouTube and Twitch channels. Yes. And all right, I guess that we can slowly start wrapping up today's kickoff. But before that, two small announcements. First of all, don't forget to follow our social media. Stay up to date with all the announcements for this and future hackathons. You can find us on TikTok, LinkedIn, X, Instagram, Facebook, and Discord. Our team is putting a lot of heart and effort into creating content for you. So you can also share some love by liking, sharing, and saving the posts. And also, don't forget to sign up for our upcoming hackathons. Next week, 8th of October, we see each other on Llama Impact Hackathon in San Francisco. But don't worry, this is the hybrid hackathon. So if you cannot be there in person, you can always join us online. 15th of November, we are hosting second hackathon with IBM, but this time you will be challenged to build something with IBM Watson X Assistant. And next one is 28th of October. We have Google Gemma 2 AI Challenge, where you can win not only amazing swag packages, but also one-to-one meeting with Google London team. And last but not least, 6th of December, we see each other on the Lokai Innovation in Healthcare Hackathon. That will happen both online and on-site in beautiful Honolulu, Hawaii. And I would like to remind you that the Q&A session is starting soon. So if you don't want to miss it, you should start heading towards our Discord now. There will be our mentor leads, but also mentors from Rhymes AI. I saw one question in the chat from Oscar, who didn't get an access to API key. He was not in the selected team, and he's asking if he can still get an access. Well, you can always try, right? On our Discord, tag Rhymes AI mentors. It never hurts to try to ask. So I would recommend that to everyone who really, really want to do this project. You never know. All right. And once again, I would like to thank you to our today's guests. You are amazing. Thank you very much. And I would like to thank you for being here today. And I wish you a happy hacking. Good luck with your projects, and we see each other on the winner stream. Bye, everyone.